All right, welcome back. So we're going to continue our look here at logarithmic functions, in which, might be a little confusing because we haven't really looked at logarithmic functions yet. We've only looked at these, what power functions and stuff. But you'll see the connection here in a little bit. We're going to continue our look, though, at these what power functions. So again, exercises 1 through 9 are very similar to the ones we just did here for the opening exercise. So we're just asked to evaluate the following expressions and justify our answers. Okay, the justification part I'm not going to worry too much about, but at least evaluate these. So again, the what power, right, of 7 gives you 49. That's what these are really asking us to do. So another way you could say this is to say 7 to what power gives us 49, and this is going to be our answer. So what power would that be? It's going to be 2. Okay. All right, for the next one, 0 to what power gives us 7? Well, the answer is there is no answer. It's not possible, right? Okay. All right, and so let's keep going here. All right, why don't you go ahead and try 4 and 5 and 6 and see what you can come up with there for those answers. All right, pause the video and give those a try. All right, hopefully you pause the video, and if not, go ahead and do it right now and give it a try, all right? So anyway, what power of 5 is 1? So 5 to what power gives us 1? Well, this one is possible, right? It is 0. Okay, the next question is what power of 1? So 1 to what power gives us 5? Well, this is not possible, right? We can't multiply 1 by itself any certain number of times, so it's not possible. Okay, how about this one? So 2 to what power gives us 16? Or what power of 2 gives us 16? So it would be 2 to the 4th. Okay, what power of negative 2 gives us 32? So negative 2 multiplied with itself a bunch of times, is it possible to make a positive answer here? Well, it's potentially possible. Let's see here. So 32, so 2 to the 5th will give us 32, right? But if we do negative 2 to the 5th, that's going to be equal to negative 32. So it's not going to be possible for us to get a positive 32 here. So it's not possible. Okay. Next one here, 1/3 to what power gives us 9? Okay, now when these problems start to get more complicated, right, when you, for example, have fractions and stuff like that, you may want to actually go about trying to solve these. So what I mean by that is we can take this problem, which maybe is not super clear about how to, figure out this answer here because of the fractions and stuff. Let's, instead of the question mark, let's make it an x, right, a variable. And let's go ahead and rewrite these to the left and the right-hand side so that we have a common base. That is, rewrite this and this so they both have the same base. Okay, so for example, 1/3, that's the same thing as 3 to the negative 1 to the x, like that. And then 9, that's the same thing as 3 squared. Okay, so now here where we have a power raised to a power, we can multiply. And we'll get 3 to the negative x equals 3 to the 2. Now, at this point, since we have the same base, and the numbers are both supposed to be equal, that means our exponents also have to be equal. So we can go ahead and just say that negative x has to equal 2, or in other words, if we divide both sides by negative 1, that x equals negative 2. And there is our answer for the power. Okay, so that required a little bit of multiplication. Okay, or yeah, it was like solving, basically, we'll say. All right, same deal here for this one. We can do a similar kind of situation as well, potentially. So again, what power of negative 1/3 is 27. So again, let's rewrite things here. This is going to be a little bit trickier though because we have that negative in front, but we can still do some of this. So for example, we could say that this is going to be negative 3 to the negative 1 to the x, and then equals 3 to the 3rd. And then if we multiply our exponents there, we'll get that it's negative 3 to the negative x equals 3 to the 3rd. But now we kind of have an issue because we have two different exponents here. two different bases, I should say. And there's no way to make these match up. Okay, you might say, but Mr. Witt, can't we do something like this? And the answer is yes. You can kind of like break that -1 out, so it's to the negative x power. But then the problem is, oops, sorry, there should be +3 in there. But the problem is, yes, we have same bases now, but we have this -1 to the negative x over here hanging out. That means we can't like use that same property like we did up here, where they are the exact same base. So again, this problem, not possible. Okay. And then finally for number 10, describe the allowable values of b in the expression what power of b to the x. When can we define a function f of x equals what power base b of x? Explain how you know. So allowable values of b must be greater than 0. If you look up here, write all the ones where these little numbers here were negative, right? That one, okay? Where they were negative, they were not possible, okay? So we want b to not be negative. And you'll notice I didn't put equal to 0 too. We also don't want b to equal 0 because, again, if you think about this example right here, okay, you can't take 0 to some power and get a number, right? 0 to any power is going to be 0. So again, we don't want to include 0. And there's one more we don't want to include too. What was the other not possible? So again, we had our two negatives that were not possible. We had our 0 that was not possible, but there's one more, and it's this one. So we don't want our b to be 1 either, because again, it'll end up being not possible. And there's our limits. All right, well, in the next video, we'll look at these examples.